Today we are going to learn Euler's method. After learning about slope fields, this takes slope fields to the next step. Euler's method, in essence, just takes small line segments and connects them to form a graph. Please follow me on page 325. At the bottom of the page, there is a purple box. Copy those steps into your notes. To start off, we're going to do a practice problem. The first stipulations that they give us are dy dx equals 2x plus 2y, and delta x equals 0.2. X equals 3 and y equals 4. They want us to find f of 4. In Euler's method, to make things easier, we set up a table. Those are the key points that you need to know to do Euler's method. Like it says in the purple box, you have to begin with the point xy specified in the initial conditions, which in this case is 3, 4. And then next, you have to find dy dx at that point, so you plug in x and y into the dy dx equation. So here it will 2 times 3 is 6 plus 2 times 4, which equals 14. And delta x they give you in the problem, which is 0.2. To find delta y, you take the dy dx and then you times that by the change in x, which gives us 2.8. And then to find the next points, you take your initial x value plus the change in x, which gives you 3.2. And then your new y value is your initial y value plus delta y, which is 2.8, which gives you 6.8. And that new point is your next point down here. Then you take those x and y values and plug it into the dy dx equation, and when you do that, we get 20, and delta x stays the same. When you plug in the new dy dx and multiply that by the delta y, the delta x, you get 4. And 3.2 plus 0.2 is 3.4, and the new y value is 10.8. You carry that point down, the new dy dx value is 28.4, and delta x is still 0.2. Delta y, when you multiply dy dx times delta x, is 5.68, which gives us our new point of 3.6, 16.48. Carry that down. Our new dy dx is 40.16, and delta x is still 0.2. Our dy dx times delta x equals 8.032, giving us our new point of 3.824.512. We're almost to 4. Our new dy dx is 56.624, and delta x is still 0.2, and delta y is 11.325. So we now are at 4, and our y value is 35.837. So in Euler's method, taking the small line segments and piecing them together, you can find values that are close to the initial point that they give you in the problem. If you look at the graph on page 326, figure 6.7, it shows you the blue line is the original graph, and the black pieces together, those are what you get in Euler's method. As the farther away you get from the original point, the more inaccurate your estimate will be from Euler's method. Please do exercises on page 328, number 41 and 43 at this time. Good job. Also, in Euler's method, instead of having your delta x going to a higher number, you can also have a negative delta x to find a value that is lower than your initial x value. The process is the same table headings, but the delta x will only be negative now. Now do exercises 45 and 47 on page 328. Good job. Now, after your practice in our tutorial, you should now know how to do Euler's method. This video has been brought to you by Ella Inman.